Hello everyone, it's me, the Cannabis Reviewer, also called Nighthawk. That's my other alias. Today on this video, we're going to go through and talk about the code that I've written for the new GROWSS system that I'm going to have. It's in addition to the Raspberry Pi, but this is an Arduino. If you've looked at my other videos, you've seen me already talk about it and upload some code. Don't bother with any of that old stuff because I've rewritten it and made it basically made it just like C. It is C++ now. It's not some hacked version of it. I'm using classes. I'm using methods. I'm using the Arduino function calls. And I got it all working and running. I don't have everything working, but I have the basics working. I have moisture sensor 1 working. I have moisture sensor 2 working. I have the BME280 working. I have the real-time clock working, so it always takes time. And those are the basic main controls. Oh, and I don't have it connected. I also have the relay working, but I don't have it connected. It goes to the wire that's not connected to anything. And I'll connect that as well, I guess, but it's not really needed for this demonstration anyway, because it doesn't take any measurements. It just turns on and off, and you're probably not going to be able to hear it anyway when I start recording the screen to show you what I've done with the new code. I'm pretty excited about it. I'm real happy with what I've done and how it's come out. And I think not only is it is C++, but I think I've done it in a way that the Arduino community likes to see it, where you have a C file and a header file together for your files, and then the class has both the variables that it needs and also the methods to use on those variables or to get those values. We'll talk about it. I'll show you every gory detail of this, every file, everything, and it's going to be cool. And of course, it's going to be open source. And I haven't done it yet, but I will be posting it to my GitHub account and also to my SourceForge account. And I'll provide links to those below so as when you get this video and you get through all of the length of whatever I talk about, however long it's going to be, in the description there will be links to go get the actual code if you'd like to play with it. You're going to need an Arduino ATMega2560. You're going to need a GROWSS base hat, and you're going to need some GROWSS sensors. Those are the moisture sensors, the BME280 sensor, and their high precision real-time clock to start off with anyway. That's a DHT22 temp and humidity sensor. The temperature on these are fairly accurate, humidity not so much. This is really much more accurate once you get it calibrated. And also, let me say, none of this has been calibrated. The only thing I've done is I've put in the real date and time on the real-time clock. I'm taking measurements, but this isn't specifically accurate. It's close, but I haven't, you got to really calibrate it. And that'll be the final step before I put it in, will be to put it into some salt water solution in a bag and with an accurate temperature thermometer that I have that's mercury based, and compare that, take some numbers at different heat levels, and then run it through my Excel spreadsheet to create my equation that I need for a calibration constant. Except it'll be a constant after the equation runs, and then hopefully everything will run the way it should. Remember, guys, nothing's linear. They think that you think this might be a linear output, but it's not. Linear output in terms of not necessarily what the voltage is, because it's I squared C, but what the value is versus what the real temperature is versus that temperature. Usually once you get your constant right, it's pretty straight. But the problem is these can turn, even without a constant, they tend to turn at the end at their thresholds. So, you'll think it's this way, but it may do one of these deals, where it goes, it may just go. So, and you'll see that in the graph in your Excel spreadsheet after you take a bunch of data points. And that's what I'll be doing. So, and I'll be posting videos for that shit too. You know me. Okay, Next up, we're going to take screenshots and do some video recording on the screen, and I'm going to talk a bunch of shit about what I've done, and hopefully y'all can learn from it. This is Nighthawk and the Cannabis Reviewer. I'll be right back to show you the code. Hello everyone, it's me, Nighthawk, the Cannabis Reviewer. Glad you guys are watching my video. We're back from showing you my Arduino, and now I'm going to show you the code. And this code is working. It's beta, but it is working. And I have a lot more to do to it, but I wanted to get through the first step. And on the previous video, when I was talking about for beginners and noobs, what to do, check all your sensors first, get them all working, and then integrate them into your main code. I've done all that. They've been integrated in the main code. Everything works. I have to admit, I didn't like the code I'd written before. I thought it was not quite really C. It was more ANSI C than C++. So I went back, and that's also why it's been a while since I've uploaded a video. A couple of reasons. One, I had the end of my grow season, and I had to transition to a new grow season, and that's taken a little bit of time. But the other reason also is I had to learn C++. I really have never had a class on C++, so, and that's fine, but that just means I have to take time and spend the hours to go through it and learn how to do it. Quite a few places online when you Google that you can go to. Check YouTube. Just check everywhere, you know. There's so many resources out there. Arduino, there's so many resources, so just go look. If you need help with that, I can help you too. Just post a comment. But let's talk about what we got. This system is going to be a little different than the other one. And as you see from the video, you didn't see any LEDs. You didn't see an RGB screen. You don't see a case, really. You don't. So one of the things that's different is we're not going to have LEDs or RGB screen. We're just going to have sensors. We will have a buzzer probably, just to go through the power on self test to let me know that it's not really testing it as much as you gotta look at it to see it's testing, but it lets you know that the test is over. Because there's not much you can do with an analog sensor to test it, you know. Not at the beginning without having the Blink app or something, a terminal, something running. But anyway, let's go through it. So it's just like the Python one. It's going to do the same thing. Monitor all of the environment in your grow box or grow cabinet. Let me shut this. That'll help read it. So it's the same as it is for the other one, except we're using an ATMega, Arduino ATMega, Grove base hat here. Same sensors we can use. Still monitors all of this. Still controls lights, an exhaust fan, and then I say water atomizer, but that's actually humidifier now through a relay, a real humidifier, because the water atomizer wasn't doing the job. It sets alarms still, and the mobile app is coming. That's the next step. First of all, you got to get the code working at a basic level, and then you slowly roll in new features, and the mobile app's a new feature. This is not working yet either, and this is not working. But with C++, I'm really hoping that the Blink apps work well enough that I can do all of this from that mobile app. That would be badass. Here's some stuff I haven't quite got done. And this is also brought back, some of it is also brought back from the last one. Maybe water the plants, change alarm thresholds. Once again, if I can get that Blink app to work for the enable disables, then I can also change those thresholds right in the app. So hopefully that's one of the reasons why I'm moving to this platform away from the Raspberry Pi. So, you know, email disable, you know, retain values also. That's an interesting issue because the Arduino doesn't have an operating system, and the Arduino doesn't have storage natively. So you have to buy a module for that. And so one of the things about the modules is there's limited resources, and they share those resources. So sometimes you can only use one module versus the other. You have to turn one off to turn one on. There's some handshaking and some shit to go on. with that. So for example, I have to use the Ethernet module. I need that for the Blink app to connect. And it has an SD card on it, which is great. Problem is, though, they both use the same serial, SPI. So you have to go through a setup where you disable one, write to the other, enable, disable one, enable the other, write to it, disable it, enable the other one. Bang, bang, bang. Something along those lines. At least that's what it looks like from the understanding that I have from reading and researching. But I will continue to go through it and see. First of all, we're going to get the Blink app working. We're going to get the Ethernet working. I'm not so worried about the storage of values right now. That's why it's here in the included later. And you could always catch more errors and create error logs and go crazy. I don't really have errors per se. What I have is I have a debug mode where it'll print out the values to the standard I/O, and you'll see that down here because I turned it on so you can actually see what's going on, because I don't have the Blink app running. So that's what I use to test it to make sure it all works. Okay, so I use the Growth base hat, and these are the connections right now that I'm making for those sensors. So the LED light is a two channel relay, basically one channel here, one channel here. So I have a light and exhaust fan on the same relay. My Grove buzzers on a different connector. 8 and 9 has a humidifier and airflow fan. So the airflow fan is the fan inside that circulates air to keep everything moving, so you don't get mold, bud rot, humidity level gets balanced, all of that good stuff. Analogs now: sensor 1, moisture sensor 2, moisture sensor 1, and then the density smoke sensor. Right now I have that there. I may end up exchanging it with another moisture sensor. I don't know. I also have a capacitive moisture sensor that I want to try out that also uses the analog port. It doesn't have the copper traces, so it doesn't corrode. But I haven't tested it yet to make sure it works or how well it works. And then I have I2C stuff. And then, of course, basically the BME280 right now. And I have a DHT, if I decide, which DHT22, if I decide to include that. That's another temperature, humidity, pressure sensor. Not as good as a BME, though. I could put it in here in D2. So I have room to grow a little bit, which is nice, because I didn't have that so much, really at all, with the hat that went on the Raspberry Pi. There were some limitations with the Raspberry Pi. So, okay, y'all new to C++, you're going to have to kind of go through this with me and go back and do some reading. I'll try to walk through it for some of you noobs like me. So if you want a good understanding of the basics of C++, there's a dude by Caleb Curry that has a pretty good video out there that kind of explains how this works. I don't know how well I can do it, but I'll try it. In C++, it's object-oriented programming. So you typically have the actual code file, the C++ file, and then you'll have what's called a header file that associates with it. The header files are the .h's right here. So the reason why you need the header file is because you need to define what type the function is, what types of data the variables are in it, and you have to do that before you call it, so the compiler knows what it needs to use. I'm not going to go into great details. I'm going to try to simplify it to make it simple to understand. If I'm not 100% accurate, too bad. Go fucking find it for yourself. But this is how I understand it. So you have header files, and they have function prototypes in them, basically, which basically the functions are declarations, function declarations as well. You could call it that declare what the function's going to be, what their types are going to be, so it has an understanding before it gets to that function and uses it what it needs. Does it have Boolean output? Does it have floats? And I'll go through that too. So before you can use that function, though, you have to include it in the C++ file, otherwise it can't find it. So when you do the includes, the compiler goes, okay, I'm going to go to Arduino H, for example, or let's do GROWSS H. Arduino H is a little different because I don't have control over that one. But GROWSS is mine. So this is called GROWSS NO because it's an Arduino setup. In the true C++ world, it would be called GROWSS.cpp. GROWSS.cpp. But because it's Arduino, we do it this way. I have heard that you can still call it GROWSS.cpp, but you have to include the loop function that this uses. But I haven't actually tried that. I try to stick with the Arduino format for this. Okay, so as we'll go through, I'll explain it, but the compiler goes to the GROWSS-H, looks at those. Not only are you going to have definitions of functions and you're going to have classes, you'll also have constants there as well. So your variables, your constants, your classes, and your methods go in all the H files, if that makes any sense. And you can organize it in any way you want. When I first started, I had one H file called GROWSS.H, or I had two, GROWSS.H and GROWSS for functions, which wasn't right, but technically you could put all this in one single ass H file and then include it everywhere. Doesn't make a lot of sense though if you actually want to reuse the code, because now you have everything in one such situation. It's not modular based. So if you write the code in a modular way where it's more of a generic input and output, and you include its header file, so it's an encapsulated piece, the C++ and header, makes it real easy to reuse that code. That's why you kind of want to do it this way. But if you're a noob, you don't even need header files. If you're a noob, you can put the definitions of the classes in this file right here at the bottom. But that's not really what like C++ is the way you do it. So if you're going to learn C++, it's okay to start off quickly getting shit done using the Arduino IDE and all that. But at some point, you need to really dig in a little bit deeper to understand how it works. So basically all of this that you see here, I do use in this particular GROWSS INO here to basically make the code work. And you see I have some commented out. The SPI is going to be, this is going to be Ethernet, and also the SD card. And this one's going to be the Blink that allows the Blink app on the Arduino to connect to the Blink server, and then that server then connects to the Blink mobile app. Okay, now we're going to start instantiating classes here. And these are predefined classes that I got from the examples from the Arduino BME examples, BME280 examples in the Arduino code. What's cool though, and I think I showed you in the last video, when you install the Arduino shit, you get examples down here where you can actually go down, and once you've installed it in the Arduino, your main Arduino program, they get shown here. You see them here. So here's the BME280 for example. So if I click on that and open it up, you're gonna see how, you open it up real quick, you're gonna see how Grove does the reading and writing of the BME. So you take their code and you use it what you can and modify it the way you want. The way they did it was they actually read the temperature and all that within the print statement. I don't, because I need to pass it to a variable. But anyway, you use that. That's what you use. And then I knew to instantiate. And then we come down here, and I'm now instantiating some of my classes that I've created in the other C files. So, for example, time. Let's open up the header file here. Let's close this so we get more room. So in time, so it's down here, GROWSS time. This is the class. And these are all the variables that you can use in that class, including string. And so over here, when I say GROWSS time, I'm instantiating one copy of the GROWSS time class locally for my use. Go to Caleb's website or YouTube channel if you are confused by what I'm saying. But you got to know a little bit about classes and shit. And I have enable features. This is actually a structure, which I'm probably going to switch to a class. I just haven't done it yet. And it's right here. I started, if you looked at my last code, my last video, I started with structures everywhere. Structures it's okay, but it's not as good as C++ classes because it's not object-oriented. And this isn't really, you can't tell this is object-oriented because there's no methods or anything, but it still follows that structure of object-oriented programming. So let's look at the H file before we get too far. Let's see. I was talking about what it does and what it has. So we have an include, and we have definitions, and I have placeholder here that I've set there for later. But these define the pin numbers for the connections to the sensors that are being connected to the base hat. This is my information, versioning information for the system. These are commented out, but these are going to be the Blink virtual pins that you use on the mobile app. So I will know if I want to look at the GROWSS name here, I will open up and connect to virtual pin 26, and it will pull that over and show me the name. We'll do that in the next video. I don't want to go too deep in that. I still got to get it working. And then we define. So, for example, let's say I was going to send that name, then I define the values farther. Actually, they're up here. Right, here's the values. GROWSS, da-da-da. So then we define the email shit, which I'm not using yet, SMS and email. Then we, as I said, we got we got a structure for enable, and this enable features allows me to turn off the email, turn on and off email, SMS. I don't really need the two files right now, but if I get the SD card working, I have it in place. The exhaust fan, turn on and off, humidity. When I say turn on and off, I don't mean actually turn off and on. I mean don't run the exhaust fan control. And a lot of this is not working yet because I want to wait to get the Blink working before I integrate it into the code, and then I can integrate both. So, but debug is working for sure, and that's what we use for the standard I/O, as I said. In the time class, we've got the set time, which we use to set the time. We have an hour, a minute, a second, a year, a month, and a day, a month. And then we have the actual date put together, the whole date. And then I define the GROWSS welcome in the H class because I use it in the GROWSS INO, and I have to have the declaration of that, or the function prototype, if you're a C kind of guy or gal. Doesn't have to be a guy, it could be a gal. Okay, so then we set some variables for the temperatures and pressures. Yes, you could pass it to the class, but there's no need. But I may change it, I don't know. More instantiations of the high-lows class, the alarms class, the lights, exhaust fan, humidity control, and blink LEDs. All these classes. And we will go through them as we go. I recommend, though, you go to the GitHub page, my GitHub page, or my SourceForge page, and download the code. As I said earlier, it will be up when I post this. It will be up before I post this video. So this is following the Arduino call style. First, you have to set up everything, and then you run. So this is don't look at all this. I'm just kind of going through all the setup, and then we'll go back over it. Oh, I went past it. And then and then you have the loop, and the loop basically constantly runs over and over and over again, and never shuts off, and that's what you run your main code in. And if I decide to change this to C++, I may try this. I'll have to call this something else. I don't think I can call it the same. Well, actually, I may not need it because I'll have the loop. I don't know yet. I'm gonna stick with what works right now. So setup. What are you doing? Well, you're setting up everything for the first time. So first thing we gotta do is set up our serial port to make sure it's working, and then we set up. And I don't have everything completely set up for all of the sensors. I just have them set up for the sensors that I have. So I have exhaust fan, which was the relay, which I don't have connected right now, humidifier relay, and light relay is all set up there. And I don't have to worry about any of the analog, I guess. Although I'm surprised it works, even though I haven't set it up. It probably defaults to analog in. So I'll need to, as you can see, as we go through this, there's always shit to add that you forget about. So you're watching in real time. Okay, so now I know. So we initialized the BME sensor. We pulled that from that code you saw. And if you don't do this, it won't work. I forgot to add this early on, and it was giving me erroneous data all over the place, and it took me a while to figure it out. Okay, and then now we're setting the features debug and the set time. So this, as I said for a second, this will be my third time. This allows you to output shit to this standard I/O. This is set, if it's set to 1, it allows me to set the time on the real-time clock module the first time through. And you do that when the battery dies or when the battery falls out or when it's brand new. And otherwise, you don't have to mess with it. You do it once and you're good. I define what the light time on and off is for both hour and minute. So basically, the light will turn on at 9 a.m. and shut off at 9 p.m. in this particular test. I define the fan variables based on the class exhaust fan, those variables in that class. They're defined right through here. The alarms are defined through here. So let's go to exhaust fan. And that is in the controls, because I know that because I wrote it. If we go here to exhaust fan, here's the class. And in that class, we have these day, night, temperatures, set points, and is the fan on. And this, and then I have, this is a common way of doing this. And they're public. I haven't made them private, so anyone could access them from any other function. And then here's the method, exhaust fan control. And the control, basically what it does is, it looks to see based on the temperature and humidity whether it needs to turn the exhaust fan on, and if it does, it will, and then if it does or doesn't, it will return if the fan is on or not. Hopefully that makes sense. So I'm basically setting those variables right here that we're going to be using down in the code to make those decisions.